morning, good afternoon, good evening, wherever you may be watching this from. This is Canadian Stuvinda with another video. Alright, in this video we are now having a revision exercise on what we have looked at so far under Calculus 2. We have looked at increasing and decreasing functions, and we have also looked at equations of the normal to the curve and tangent to the curve. Alright, so in this video we're only going to do question 1. Then in the next video we're going to do question 2, which has 4 sub-questions, A, B, C, and D. Question 1 reads, find the range of values of t for which v is increasing if v is equal to 4t cubed minus 3t. Okay, so when you see a question like that, the first thing that you should think about is for you to know the range of values of t where it is increasing, you first need to differentiate. Because when you differentiate and then you say in this case, dv, dt, you set it equal to 0, you are going to find what we call stationary points. If a curve is going like this, okay, for example, a curve is increasing. Let me give an example of a parabola, okay? We can have a parabola, okay? So we have a parabola where it's a curve, for example, y is equal to x squared, okay? It's sort of like this. It comes like this. So when it's going down like that, it means it is decreasing. Then it reaches a certain point where it's going to turn and start going like that. So that certain point there is what we call the turning point or the stationary point. Stationary point. So at that turning point or stationary point, if you draw a tangent line there, for example, one like this, if you draw a line like that, I hope it's visible, one like this, touching the curve at that point only, you are going to find that along that tangent line, dy dx is equal to 0. So that's what we are going to use. So we have the equation v is equal to 4t cubed minus 3t dv dt is equal to 12t squared minus 3. So you have remaining an equation 12t squared. This is not x, sorry for that. It's supposed to be t. 12t squared minus 3. And then to continue, you're going to say when dv dt is equal to 0, 12t squared, okay, minus 3 is equal to 0. And then we're going to take the negative 3 to the other side of the equation. It's going to become 12t squared is equal to positive 3. You divide by a 12, you divide by a 12. 12 can go into itself a 1, into 12 it can go a 1. 3 can go into itself a 1, into 12 it's 4 times. So you're going to have t squared is equal to 1 over 4. So t squared is equal to 1 over 4. And then to find the value of t, we're going to say we take the square root, okay? And then plus or minus like that. After we do plus or minus, because we're taking the square root on both sides of the equation, we need to apply the plus or minus. The square to cancel with the square root. T is going to be equal to plus or minus 1. Square root of 1 is 1, square root of 4 is 2. So plus or minus 1 over 2. Okay. And then our aim now is to substitute t is equal to half into v, and then we substitute t is equal to negative half into v. Well, we have 2 coordinates, and then from those coordinates we are going to determine where the curve is increasing and where the curve is decreasing. Okay. So we are going to say when t is equal to positive half, v is equal to 4 multiplied by positive half cubed minus 3 multiplied by positive half. It's going to be 4 multiplied by positive half cubed is a 1 over 8 minus 3 over 2. Okay, and then 4 can go into itself a 1. Into 8 it can go 2. So it's going to be 1 over 2 minus 3 over 2. and this is going to become minus 2 over 2, okay? And then in this case, your v is going to be equal to negative 2 into itself. 2 into itself is a 1, into 2 it's a 1, so v is a negative 1. The first coordinate will be half comma negative 1. Okay, so what we're going to do is this. The first coordinate is positive half comma a negative 1, and then we'll say when t is equal to what? A negative half in this case. It's going to become v is equal to 4 multiplied by negative half cubed minus 3 multiplied by negative half. So it's going to be equal to 4 multiplied by negative half cubed is a negative 1 over 8 because of the odd power. Okay, and then we're going to say plus 3 halves. This is going to become 4 can go into itself a 1 into 8 is a 2 is equal to negative half plus 3 halves. So it's going to be equal to a positive 2 over 2. 2 can go into itself a 1 into 2 it's a 1, and then we're going to have v is equal to a 1. So second coordinate is negative half comma a positive 1. So those are the two stationary points given by the function v. Okay? So we can clean up now. And then we have those 2 points. Then we're going to use our x or y plane to plot these 2 points so that we can just show how you are supposed to answer them. Okay, so that is the x or y plane like that. And then you have your y-axis, you have your x-axis, you have your 0. And then you're going to have your positive half comma a negative 1. So a positive half will be somewhere here. Negative 1, okay? Negative 1, I can say, is somewhere here. And then you're going to have, let's write it down. So positive half comma negative 1, and the coordinate is going to be somewhere there. And then the next one is going to be a negative half. Negative half can be somewhere here. And then a positive 1. Positive 1 can be somewhere here. So it's going to be there. So we have the 2 stationary points. Now we don't know how to sketch the graphs. How should we sketch the graph? So first of all, we need to think of values of t, okay, from the function. We have the function v is equal to 4t cubed minus 3t. So let us think of values of t that are less than, in this case, values of t less than negative half, which is a negative 1, right? So it's going to become, let me just do a rough working, 4 multiplied by a negative 1 cubed minus 3 multiplied by a negative 1. So it's going to just be 4 multiplied by a negative 1 plus 3. So it's going to be negative 4 plus 3. And then in this case, as you can see, v is going to give you a negative 3. So for a negative 1, in this case, if you look at the function, so we're plugging in negative values, okay? We found that if you plug in a negative half, they're going to be positive 1, and now we have plugged in a negative, in this case, a negative 1, and then now we're finding a negative 3, okay? So negative 3 is somewhere this side. Okay, so negative 3 is this part of the graph. Let me try to write it in a way that you can understand. So if I were to extend this, it means that your negative 3 would be there, and then your positive 1, okay, your negative 1 would be there, so the coordinate would be there. So what he's trying to say is that the graph is coming like that, okay? So upon us knowing that, it means that the graph is coming from down there, and then it tends. So it's increasing, and then it starts decreasing once again. That's how the graph would look. Okay, I hope that's clear. And then we have the next part, which is a positive half comma negative 1, which is right here. Let's think of values of numbers less than a positive half. We can even try okay, since we are thinking of values of numbers less than positive half, let's try something like a 0.2. But for that, I would need my calculator. Okay, so if we plug in a 0.2, it will be 4 multiplied by a 0.2, okay, cubed, and then minus 3 multiplied by a 0.2. What you're going to have is a what? A negative answer. And it's going to be a negative 0.5. So it's like when you have a lesser number, you are going to have something. So for example, a 0.2 can be somewhere here. Somewhere here is 0.2, because half is 0.5. So somewhere there, and then you're going to have a 0.5 somewhere here. So your coordinate would be there. Okay, so 0.2, and then here approximately negative 0.6. So it means that the graph is coming from this same point, it's going to go there, okay? And then if you try a number greater than half, for example, you can try a 1, it's going to be 4 multiplied by a 1 cubed minus 3 multiplied by a 1, which is just 4 minus 3. You're going to have a positive 1. So for a positive 1, here, if there's a positive 1, you are going to have a positive 1 right there. So it means that the curve would be increasing. Okay, and that's how it would look. I hope that's clear. Okay, so that's how it looks. And then in the question they said, find the range of values of t for which v is increasing. For which v is increasing. So we are going to conclude and say, therefore, the range is, for which v is increasing, we're going to say v, rather not v, this represents t. So in the x-axis represents t, in the y-axis represents v. So we're going to say, therefore, the range is t is less than a negative half, comma, t, again it's increasing after it goes from, so it's increasing in this section, okay? So it is increasing after the turning point. Then here, it is increasing in this section. It is increasing before the turning point. I hope you can see that it is increasing before the turning point. That's why I said c is less than negative half, and then t has to be greater than positive half. That is the range. So this is using the graphical method. We are going to use another method to know decreasing and the increasing functions, how to tell. We're going to use another method later, but for now, we need to know the graphical method. Thank you so much for watching this video. If you stayed until the end, I just hope you can follow for more videos like this. This has been Cornelius with another video, and bye-bye.